Let's go over the RhinoCAM interface. So first off, you want to make sure that you've opened the correct version of Rhino. In our case, that's going to be Rhino 4.0, but it's going to have a blue icon instead of a black icon. In clicking on that blue icon, you will not only load Rhinoceros, but also the RhinoCAM plugin. You can verify that by looking at the menu at the top here and seeing RhinoCAM in your menu bar. So, if you see RhinoCAM, let's move on. There are two basic palettes that we're going to be working with. And you'll see right here we have the Machining Operations browser. We'll open that up. And we have the Machining Objects browser. Machining Objects browser has a series of tabs, each with its own function. The main function that we're concerned with is going to be the Tools function. What the Tools function does is it allows you to create a tool for use in milling. So essentially, you're going to enter all of the different pieces of information about the tool bit that you're working with to mill out your object using this interface. You can save it as a new tool, you can save edits to the tool, you can delete the tool, etc. You can also take care of saving and editing operations through these buttons here. There is also a Regions tab, and the Regions tab allows you to create machining regions within a composition. We'll talk more about that when we get into the actual methods of milling. K-Base, I wouldn't really worry about the K-Base tab. When we look over here at Machining Operations, the Machining Operations palette, this is where you're going to perform the majority of actions and operations towards the creation of an NC file. An NC file is the information that we need to mill with. So there are two main tabs. There's the Program tab and there's the Simulate tab. The Program tab is broken into three basic sections. You have the machine setup, the stock, and machining operations. For the machine setup, this is where you can actually list specific information about the machine itself, including this, which is critical, the post-processor. Every single CNC on the market has its own sort of private language, for lack of a better term, that it uses to understand the direction of movement for the machine. And if you're not using the right post-processor, when it comes to milling your information, you can damage the piece or the mill. In the case of our main mill, the 4-foot by 4-foot Techno CNC, we want to make sure that our current post-processor is set to the Techno easel. You'll see that we also have one for our Roland, and if you're working in millimeters, you can work specifically with a Techno easel for millimeters. But we're not, we're working in inches, so we're just going to use the standard Techno easel. Under stock, this is where you actually assign information about the material you're working with. So for example, you can assign how big the piece of the stock is. You can actually align the stock to the piece you plan on milling. And you can even set material information. For our purposes, we're not really going to play with the material button too much, as we're going to learn all the basic characteristics of different materials by hand. Thirdly, you've got the machining operations section. And this is where you specify the type of milling operation you want to undertake. Do you have 2-axis milling? For the most part, we'll deal with engraving. 2-axis milling is essentially two-dimensional milling, where depth is something that is not variable. We have, and you can actually perform depth cuts or variable depth cuts with 2-axis milling, but for the most part, it's about singular depth. With 3-axis milling, we have a whole series of options that allows us to control variable depth. So we'll use this for topographies and any sort of three-dimensional surface operations. Our mill is both of our mills are 3-axis mills, so we don't have to worry about 4-axis and 5-axis. They won't do us any good. Finally, we have holes. Holes is just like it sounds like. You can use the holes function to drill, to tap, to bore, to reverse bore, etc., etc., etc. Finally, down here, we have a sort of Windows Explorer style hierarchical tree. And this gives us at a single glance all of the basic information about the milling operations we're setting up, including our stock, the post-processor we're working with, and then below here, all the different sets of milling operations we create. Finally, before we move to simulate, within the programs area, we have all of these tabs right here. These tabs allow us to control information about visibility in our Rhino window. So that includes things like the stock visibility, material texture, which we're not concerned with that, so that's not a big deal. toolpath visibility, so you can actually turn on the toolpaths. Oh, I can't display levels because I haven't actually made anything yet. And, excuse me, CSYS is not something that we will ever contend with. If we click on this second tab right here, you'll see that we also have the ability to preview the milling operation. So in other words, I can hit play on this if I had a milling operation set up and watch a virtual representation of my file being milled here. This is a great way to just get an idea as to whether or not you've selected the right milling operations. In our next demonstration, or our next exercise, we're going to take a look, next video, we're going to take a look at the basics of creating geometry in Rhinoceros for the purposes of milling.